This video demonstrates the installation, applications, and capability of the Kuka industrial robot installed in Future Technologies Lab located in Site Building, Room 3040, University of Ottawa. The installation of industrial robot system comprises of several subsystems. The robot arm, as known as manipulator, which is KR6R700, which comprises of highly precise and accurate motors along with the link arms that physically move the robot arm. The controller, which is KRC4, which essentially executes the user programs and controls the arm. Another major task provided by the controller is ensuring user safety, which we will talk about shortly. The teach pad, this is the interface that a user uses to execute and even program the robot. Programming can be done in another computer as well and transferred to robot via network or USB thumb drive. However, TeachPad can be used to also manually move the robot using inbuilt 60 mouse and keys. Safety system. This includes a physical cage-like structure, a door state detection mechanism to detect whether it is open or closed, and 3 emergency stop buttons to further ensure user safety. These mechanisms work together to ensure that everyone in the lab is always at the safe distance from the arm when it is operating. The access within the cage is only limited to certified personnel, and the operating of robot program requires mandatory training to ensure everyone's safety. An external I/O card to add additional control inputs and status indicators to the robot system. The arm consists of 6 motors and is able to position an object in any point in space along X, Y, or Z axis with the desired orientation profile about X, Y, and Z axis within its workspace limits. Besides positioning an object with accurate orientation profile, the robot system also offers wide variety of inbuilt motion profiles that makes path planning algorithms to leverage various motion types. This way, a user can focus more on applications instead of rewriting motion algorithms for every program a user writes. The different types of motion profiles supported by this installation include point-to-point motion, circular motion, linear motion, spline point-to-point motions, spline circular motions, spline linear motions, spline blocks, which are custom spline motion profiles, and approximated motions, which are approximated continuous motions. The robot system installed can be used to develop applications in various fields such as robotics, automation, motion profiling, path planning, and state machine design. The demonstrations shown later in the video will demonstrate each of these applications. The first demonstration shows different types of motion profiles that the robot is capable of executing. Notice that the robot dynamically adjusts the orientation of the object, which is the tool tip, in some motion profiles. The velocity of arm is also changing based on the motion profiles. This ensures that the robot system is safe and reaches every programmed point in space with the given constraints. The second demonstration shows movement of different axes when isolated. This example also demonstrates the continuous path planning using approximated points in space. The third example demonstrates the reconfiguration of tooltip. This helps users to focus on objects orientation and position instead of robot's individual axis angles. By attaching a drumstick to the gripper, configuring the drumstick to be the tooltip, and combining different motion profiles, the system can also play music. This example also demonstrated the automation application that can be developed using this system. Depending on which input is present, the controller will execute different programs. The fourth application demonstrates that it is also possible to create different motion profile dynamically, depending on user's input. In this application, the controller executes the program and waits for the user to provide it a MIDI file, which is a file that contains song information, which is similar to a sheet music. Then it will ask for the desired tempo a user wants the robot to play a song at. Afterwards, it will ask if the user wants the robot to transpose the song to a particular key. After getting all of this information, it will plan the motion in one shot and play the song by sending the motion profiles to the manipulator. This project is an initiative of Faculty of Electrical Engineering and Computer Science, University of Ottawa.